This is kind of weird.
What's that?
Check this out. This is a tape of some raw footage of the blimp mostly taking off and landing. The people over at Goodyear let me borrow it. They said we could use it for a documentary.
Right.
Yeah, but check this out. Here's footage of the blimp taking off. It's strange. It almost looks like a plane taking off, doesn't it?
What do you mean?
I guess I just really never noticed it before, but watch this. Right there. See at the front of the blimp, the nose lifts up during the takeoff? And that continues while the blimp ascends into the air. I mean, why would that be? If it's filled with helium, wouldn't the blimp just stay level as it floats straight up? Why would the front go up first?
Actually, I think I might have an idea. Check out this rough draft of the poster that we made. See those two balloon-type things inside of the envelope? The aft and fore ballonets.
Yeah.
Well, we still haven't figured out what they're used for, right?
Right.
I think that's where you'll find the answer to your questions. We need to find out what the ballonets do.
Well, it's worth looking into. Here we go. I'm on the Goodyear Blimp website.
What's it say?
Let's see. The ballonets are air chambers inside the blimp's envelope. The fore ballonets up near the nose of the blimp, and the aft ballonets further back.
Right, like on our poster.
Together, the ballonets can be used to control the upward or downward movement of the blimp. And here it says that they can be used to trim the ship in a nose-up or a nose-down situation. So they use the ballonets to aim the nose up or down. Sounds like you were right.
Yep. I love it when I'm right.
But there's more to this. It says that as the blimp rises, the helium in the envelope expands. And as the helium expands, air is released from the ballonets to keep the pressure steady inside the envelope. So as the blimp goes higher, the ballonets deflate. During a descent, the ballonets are slowly filled back up with air from the outside of the blimp.
Well, why does helium expand as the blimp goes higher?
It doesn't really go into that right here.
We should probably find out.
Yeah, I wonder who we could ask.
I wonder who would know exactly how and why the ballonets work. I bet one of the pilots would know.
Let's try and set something up.
So are we all set for the interview?
Yeah, Captain Kynette said he'll be ready for us in a few minutes. I kind of prepped him on the kind of questions we had lined up for him. He said that there are certain laws that dictate how gas will react in certain circumstances. He said it's important that we learn these laws and understand them. It looks like that's going to be our focus for the day.
Do you want to tape an intro while we're out here?
Sure.
Rolling.
In our research, we've discovered that making the Goodyear blimp float in the air is more complicated than just filling it up with helium and letting it go. There are laws that dictate how gases will behave under certain circumstances. And we've learned that we must take these gas laws into consideration as we've searched to find out why and how blimps are able to fly. We're here at the Wingfoot Lake Airship Base in Suffield, Ohio, and today we'll be talking with Captain Kynette, who will help us learn a bit about gas laws. So, Captain Kynette, what are ballonets?
Ballonets are the two air cells that are inside of the envelope. They're like bags inside of the bag, and they get bigger and smaller with changes in temperature, changes in altitude, and the pilot can change those manually or it can happen automatically. It just depends on what the pilot needs them to do.
From what we understand, there are certain laws of the nature of gas. What are some of these laws?
Well, essentially, there are two types of laws that we have to deal with. The change in pressure as we go up and down in altitude is one of them, and the other one has to do with temperature change. As we go up in altitude, like I was saying, the outside air pressure is decreasing, so the helium is expanding. And as we come back down, the atmospheric pressure is increasing, so it's starting to push in on the blimp and actually increasing the pressure on the ship, and you have to be putting some air back in there because of the contraction of the helium. Vice versa, when you go up in altitude, it gets cooler. So as you go up and out to the helium is going to start contracting because as things get cooler, this gas gets cooler, it starts contracting. And when the ship comes down to where it's warmer, or if the ship's just sitting on the ground and the sun's beating on it, the sun's going to really heat the helium and it's going to start to expand. Therefore, to keep the same pressure in the ship, some air starts coming out of those air cells, and that's how we maintain a constant pressure when you have changes in the temperature. The helium expands when it gets hotter, some air comes out. When the temperatures drop, the helium starts contracting, and you pump air back in to keep it at the same pressure.
Why is there less pressure higher up in the atmosphere?
Well, essentially, you have to think of air as having weight. And if you think of like a column of air going all the way up into space, the weight of that air all the way down to the ground is pushing down on the weight of the air, or the air down close to the ground. The higher up you go, the less air is pushing down on that air that's already there, so there's less pressure. So there's less air pushing down on the existing air the higher up you go, so therefore you have less pressure.
Why is it important to maintain pressure on the inside of the blimp?
Well, we have a limit as to the amount of pressure that we can keep the helium and the air at inside the ship. If you didn't have it at a certain pressure level, then essentially what happens is you lose the structural integrity of the bag because there's nothing inside of there to hold it in the shape that it is. So if you were to take it up to altitude and then to come back down where the helium is starting to be compressed, the whole side of the bag would start getting wrinkles in it, like a big prune. It doesn't fly real well like that. It doesn't look good, and you can really do a lot of damage. So without keeping the pressure on in there, you essentially lose a structural integrity, and you can lose an airship.
When there's more air pressure outside of the blimp, like when it's close to the ground, the gas inside is contracted. And then, as it goes up into the air pressure outside of the blimp decreases, so the gas inside expands.
That was one of the gas laws that we learned. The other one deals with temperature.
As heat is increased, gases expand. When they're cooled down, gases contract.
Flying to different altitudes in a dirigible wouldn't be possible without ballonets and pressure valves. They counteract the expansion and contraction of a lifting gas. Ballonets are airbags that are filled with air as the lifting gas contracts and then emptied as the gas expands. Discharge valves, called pressure valves, let gas escape if the pressure inside the envelope becomes too great. Without this valve, a blimp could blow out like in this pressure test. This test was done on purpose while the blimp was on the ground. Imagine what would have happened if the blimp had been at high altitude. Even though this technology is over 100 years old, it's still important today. The Lockheed Martin Company is using them in a plan for a new high-tech lighter-than aircraft. The unmanned airship will be used as a platform for electronic equipment and will fly twice as high as a commercial jetliner. Space-age solar panels will collect energy to run its electric motors, and computers control its flight. But it still uses old technology to keep its shape constant at sea level or while flying 13 miles straight up.